Very good evening, Likita. Likita, can you turn on your camera? Jitendra, Shravan, Advait, all of you turn on your camera. Pranav. Okay. So, Likita, we are on second chapter of chemistry. Is matter around us pure? And in this, we have done what are pure and impure substances. We have done true solutions, suspensions, and colloids. So, true solutions, suspensions, and colloids, they are the different types of mixtures which we observe. So, these are the different types of mixtures: true solutions, suspensions, and colloids. Okay. Now we will be continuing with this chapter. So in the last class we had done physical changes and chemical changes. So again we are starting from here. What are physical and chemical changes? And then we continue what are elements. We'll see the properties of elements. We'll be able to classify physical and chemical changes also. Then we'll see what are compounds. And with this, the chapter will get over. Okay. So what are physical and chemical changes that we have to see? Then we have to see what are elements. Okay, one rule we are going to impose on you all people. First of all, your camera should be on. And secondly, whenever you need to leave the class, okay, I think I have informed it earlier also. Just I'm reminding you that whenever you need to leave the class in between, maybe of any reason, so just inform, either message me or just you can speak up, interrupt me, and then leave the class. It didn't look if you are there and suddenly you disappear from the chat. Advait, is there any problem in turning on the camera?
Good
Advait,
evening, sir.
yeah, good evening. Is there any problem in turning on your camera?
Sir, I'm clicking on it, but it's not owning only. I'll rejoin.
Okay, just 1 minute. Just 1 minute. Okay, can you see a click link over there? You might have got a prompt to turn on your camera. Okay. Pranav, what about you? Okay, let's continue. So physical and chemical changes. In the beginning, we had studied about the physical changes in our junior classes. So what do we say a physical change?
There a change in objects physical properties which doesn't bring out a new substance.
Yeah, a change in physical property. So what is a change in the physical property?
Like shape, size, state of
Yeah, you have the change in shape, change of size, change of state,
Change in
change of state,
appearance.
change in appearance. So these are the changes which we generally call as the physical changes. So whenever a substance undergoes a physical change, there will be generally a change of shape, size, state, appearance. These are the things that we'll be calling as the physical change. For example, we have ice changing to water. So ice changing to water is a physical change. It is a change of state. You have folding of paper. Okay, folding of paper to make a board. So folding of paper, this is a physical change. What about cutting a paper?
Sir,
Is
physical.
cutting of,
Sir, it's physical.
yeah, it is also a physical change. And as even after this cutting of paper, it is still paper, and the properties of paper are still there. Okay. So we call this as a physical change. Cutting of paper is a physical change. Folding of paper is also a physical change. Cutting, okay, what about this? Cutting of wood to form table.
Sir, physical change.
Okay. So cutting of wood to form table. This is
Sir,
also a physical change. Uh, Breaking a glass,
physical.
physical change. Okay. So all the changes which we have seen, they are all physical changes. What about a burning of incense stick?
Sir, chemical change.
It is a chemical change. Okay. So burning of an incense stick, it is a chemical change. Here we observe that a new substance is formed. Okay. There is a change in the properties of the incense stick. So now it is a chemical change. So uh, if, out of the physical changes, some of the physical changes may be reversible, some of the physical changes may not be reversible. Okay, so do not confuse your changes, physical and chemical changes with reversible and irreversible changes. Okay, so some of the physical changes, not all, remember, some. Some physical changes can be reversible and some physical changes cannot be reversible, they can be irreversible. They are irreversible. Okay. So some of the physical changes we observe, they are reversible. Some of the physical changes, they are irreversible. Okay. So out of these changes which we have listed out, can you tell me the changes which are reversible?
Sir, can you repeat?
Out of the changes that we have listed out, which of them are reversible?
Sir, ice changing to water, folding the paper are reversible.
Okay. And is there anything else?
No, sir.
No. Okay, all the others, they are irreversible changes. What about mixing of sand with chalk powder?
Reversible, sir.
Is it
Sir,
a,
it is not
is it a
correct.
is it a physical change or a chemical change?
Physical change.
Physical change.
Okay, it is a physical change, and is it reversible or irreversible?
Sir, reversible. We can do
Yeah,
filtering of
yeah, it is also a reversible change. Okay. So now let's see the chemical changes.
Sir, I have a doubt.
Yes.
Sir, burning of candle, is it physical or chemical?
Okay. Okay. Just 1 minute. So we need to discuss this burning of candle. Okay, let's see the doubt here. What happens during the burning of candle?
Sir, it can be listed as both physical and chemical change, no, sir.
Okay. See, initially you have your candle, and so in which state do you have your candle? Is the candle in solid state or liquid state?
Solid.
Solid.
Solid state. We have candle in the solid state, and on the candle we observe here a candle flame, right? So this is the candle flame that we observe over here. Now See how it happens. First, the candle which is in the solid state, it melts over here. The candle melts, and you have here candle in the form of liquid. So change from this solid state to the liquid state. Is it a physical change or a chemical change?
Sir, it is physical.
It is a physical change. Then with some more amount of heat, this liquid candle changes into vapor state. See what happens. So first you have your solid candle. Your solid candle is changing to, or solid candle changes to liquid state. Then this liquid candle changes to the gaseous state, which forms the candle vapors. Okay. Now it is the candle vapors which are burning to form the flame. The flame that we observe, this flame is the region where the candle flame, the candle vapors are burning. Okay. So in this region, we have those candle vapors which are burning over here. Got it? So in this solid, in this, when the candle vapors are burning, so burning of the candle vapors, your candle reacts with oxygen to form the other products. It can be carbon dioxide, water, and different other products are formed. So now this is a chemical change. If you are just talking of burning of candle, so this is a chemical change. Okay. For the complete process of the burning, so it involves both physical as well as the chemical change.
Okay, sir.
Okay. So in the what happens in a chemical change, when we say a chemical change, there is a change in the properties of the substance and a new substance is formed. So here, when we say a chemical change, there is a formation of new substance. So there is a formation of new substance with entirely different properties. So the candle flame, or if anywhere when you observe a burning of thing or a formation of a new substance. So if there is formation of a new substance, so then it is a chemical change. Got it? So for example, if you have, see, consider this mixing of iron and sulfur. So what can you say about this? Is it a physical change or a chemical change?
Sir, we can. I didn't understand actually.
Okay. See, if you are just mixing iron and sulfur, so iron and sulfur, they are not that reactive that they can start reacting on their own. They cannot start the reaction on their own. So that is why here this mixing of iron and sulfur, it is just a physical change. It is a physical change. As no new substance is formed, whatever substances are there, you have iron and sulfur. So these, they do not lose their properties. Their properties are still there. So if you have a mixture of iron and sulfur, here you have iron and sulfur both mixed. You mixed it up well, and now if you bring a magnet near, so if you bring a magnet near it, so the magnet will be able to attract the pieces of iron. The pieces of iron from this mixture will be separated out with the physical method of the magnet. So I can say that the properties of iron have not changed. They are still there. So can I say that a new substance is formed?
No, sir.
No. So here we don't have any formation of any new substance. So it is a physical change. Okay. Now, once I start heating it, so suppose I heat this mixture. So let's say now I am heating this mixture. I am allowing fire to heat it up. So when I heat the mixture, so iron now starts reacting with sulfur to form iron sulfide. You will have formation of iron sulfide. So this iron sulfide which is formed with formula FeS. So first of all, it will be mixed up in a fixed proportion. And now if you bring about, if you now if you bring once iron sulfide is formed, so if you bring magnet near this iron sulfide, now it will not be able to separate out iron and sulfur. Now it cannot separate out iron and sulfur. Got it? So we have here a new substance is formed, okay, which is iron sulfide. So this process is a chemical process. Got it? So this is a chemical process. Heating of iron and sulfur together, it is a chemical process and it gives us a new substance, iron sulfide. Here, new substance, iron sulfide is formed. Okay. So, formation of the new substance, that is iron sulfide is there. Understood the difference between physical and chemical changes? The next is curdling of milk. So, or formation of curd from milk. We have formation of curd from milk. So what about this process? Is this process physical or chemical?
Sir, chemical.
Okay. Formation of curd from milk. So initially the milk has uh, different substances in it. For example, milk has lactic acid, it has proteins, it has some amounts of water in it. Once you add some amount of curd to it, so chemical reactions start taking place and they start changing the nature of the substances. For example, if you have lactose in the milk, lactose in the milk starts getting converted to lactic acid. Okay. There are different other changes also which occur. So now you are having a change in the properties of milk. The properties of milk have now changed. Okay. So these changed properties of milk. Okay. So here the curdling of milk or formation of curd from milk, observe that the changes are taking place in the nature of the substance and we have the formation of new substance. So this process is also a chemical change. This process is also a chemical change. In the similar way, cooking of food is also a chemical change. When we are cooking the food, we are changing the nature of the substance. The nature of the substances is being changed while cooking the food. So that is also a chemical change. So everyone understood about physical and chemical changes? Any doubts about physical and chemical changes? Okay, what about this process? Tell me whether it is a physical change or a chemical change. Dissolving salt in water. So dissolution of salt in water, whether it is a physical change or a chemical change.
Physical change, sir.
It is a physical change. So how it is a physical change and not a chemical change?
Sir, because we don't get a new substance.
Okay, we are not getting a new substance. Also, it can be separated out by the simple methods of boiling or evaporation. You can separate it. So with the simple method, it can be separated. So dissolution of salt in water, it is a physical change. Now we'll see about the different elements. What are elements and compounds? Here you are given some of the questions over here. Let's try to do them. You have to classify the following as chemical or physical changes. So cutting of trees, is it a physical or chemical change? Yeah, Harshit, is it a physical or a chemical change? Harshit,
Yeah, sir.
yeah, cutting of trees, is it a physical or chemical change?
Well, it's a physical change.
Okay. Melting of butter in a pan,
So it is again a physical change because no change in its chemical composition.
yeah, we are not changing the composition, we are just changing the state. So it is a physical change. Likita, what about rusting of Almira? Is it a physical or a chemical change?
Sir, it's chemical change.
It is a chemical change. So how it is a chemical change?
So because a new substance is hydrated.
Okay. Here in the rusting of Almira, a new substance is created which we call as the rust. And the properties of rust, they are different from the properties of iron. So a new substance is created which is rust. Then boiling of water to form steam. Is it a physical or chemical change? Boiling of
Physical
water.
change, sir.
Yes, boiling of water is a physical change. Passing of electric current through water and the water breaking into hydrogen and oxygen gases.
Chemical change, sir.
Yeah, it is a chemical change. It is making a change in its composition. So it is a chemical change. Then dissolving common salt in water. This we have
Physical change.
already physical change. Making a fruit salad with raw fruits.
Physical change.
Okay, it is also a physical change. But so all of you, I think, have understood well about the differences between physical and chemical change. The last one is burning of paper and wood.
Chemical change.
Chemical change.
So the next topic we are starting with elements. So what are elements? See, whenever we talk of element means the basic structural quantity. Okay. So when we say element, so when I say element, it is the basic structural quantity that is present and is pure. When I say element, I am actually talking it to be pure. Okay. So what are elements? Yes. Can anyone define what are elements? So basically speaking, an element, it is a substance, or some people say that it is a chemical substance that cannot be broken down further. So it is a chemical substance that cannot be broken further. So you can also say that it is the purest form of matter. The matter in its purest form. The purest form of matter. So when we say element, so I mean the purest form of which it is made up of. So for example, if I take any substance, suppose I take here some amount of water. So here I am taking water. Now this water is made up of some tiny particles. Water is made up of tiny particles. This you learned in your first chapter. In your first chapter, you learned that matter is made up of tiny particles. Okay. So these tiny particles, if they cannot be broken down further, those tiny particles which cannot be broken down further, so these particles, they are called as element. These particles which cannot be broken down further, they will be called as elements. But we know water has the formula H2O. So water itself consists of two types of particles. So the molecule of water, it can be broken down into still smaller pieces. So the molecule of water can be broken down into still smaller pieces, which are, we can break a molecule of water into hydrogen and oxygen. So here you see that each molecule of water, it contains hydrogen and oxygen. So the bigger circles, they are representing oxygen, and the smaller dots, they represent hydrogen bonded to it. Okay. So we have here hydrogen and oxygen bonded with each other. So water itself is made up of H2O. It is made up of two types of substances. Made of two types of substances. So I can break water. I can break this water to form hydrogen and oxygen. So how can I break this water? To break water, we need electric current. So when you use electric current, the water over here, water breaks into two parts. It gives us hydrogen and oxygen. Okay. The hydrogen and oxygen which are produced, they cannot be broken down further. So out of these, which we have written here, we have written water, oxygen, and hydrogen. So which of them is an element?
Sir, hydrogen and oxygen are elements, whereas water is a compound.
Yes. Hydrogen and oxygen is an element, whereas water is a compound. So when we say water, water is a compound. It is made up of two atoms of hydrogen and one atom of oxygen. So here, I think everyone is clear with the definition. What are elements? Anyone having any problem with what are elements?
No, sir.
So we all know now what are elements. The substances which cannot be broken down further into pieces, they are the elements. And if we identify elements, so how many elements are known to us?
Sir, 118 elements.
Yes, we have 118 elements. Out of them, only about 107 or 8 they are naturally occurring. The rest of them they have been artificially created. So let's see a compound. What is a compound?
Sir, chemical composition of two elements.
Okay, only two.
Two or
Sir,
more elements.
substance formed by combining two or more elements is known as a compound.
So when two or more elements combine together, when two or more elements combine together in a fixed ratio, so what are compounds? When two or more elements combine together in a fixed ratio, it is called a compound. And we'll see different examples. So in a compound, the elements are always joined together or combined together in a fixed ratio. For example, we observed here H2O. Harshit?
Yes, sir.
So I think what advantage you people feel by turning off your cameras? So they are always combined in a fixed ratio. For example, H2O, CO2, NH3, sodium carbonate, Na2CO3, okay, HCl, H2SO4. So we observe here that a compound consists of two or more different elements combined together in a fixed ratio. So here in the first one, we observe that water is a compound which is formed by the combination of two atoms of hydrogen and one atom of oxygen. So from wherever you take water, even if you take water from your tap, you take water from RO, you take your Bisleri water, whatever water you take, it will consist of two atoms of hydrogen and one atom of oxygen. So here in water you will always find the ratio of hydrogen and oxygen in the ratio 2:1. There will be two atoms of hydrogen and one atom of oxygen. Similarly, for carbon dioxide, they will always combine in the ratio of 1:2. For NH3, for one atom of nitrogen, there will be three atoms of hydrogen in each molecule of ammonia. This NH3 is ammonia. If you have sodium carbonate, so in case of sodium carbonate, you have two atoms of sodium, one atom of carbon, and three atoms of oxygen. So,
Yes.
बंद करो इसको. Okay, so in H2SO4 also we observe that each molecule of H2SO4 consists of two atoms of hydrogen, one atom of sulfur, and four atoms of oxygen. Okay, so all of them, they are compounds and their properties are different from their combining elements. For example, the properties of water, they are different from the properties of hydrogen and oxygen. The properties of carbon dioxide, they are different from the properties of carbon and oxygen. The properties of ammonia, they are different from the properties of nitrogen and hydrogen. So all of them, they are compounds. Understood everyone the difference between element and compound?
Yes, sir.
Yes. Anyone having any doubt? So I think we can start with questions now. Let's start with question of this chapter. Okay, see the first question. Separation of, okay, there is, I think, some other thing also. Separation of substances is also there. Okay, let us also see separation of substances. How can we separate out different substances? So for the separation of substances, we generally do for the case of mixtures only. So in the case of mixtures, we will identify the different methods of finding out or separating the contents. We'll see how the contents of different substances can be separated out. For example, we have these methods. One of the methods is, simplest method is hand picking method. Then we have sieving. Similar method is filtration. Then you have sedimentation and decantation. Sedimentation and decantation. You have distillation process. Evaporation process. We'll talk of each of them and we'll see when we can use which process. Evaporation. You have fractional distillation. And crystallization. So these are different processes by which we can separate out two substances. A mixture of two or more substances can be separated out by these uh, by the. There are some more of them which I have not listed over here. For example, you might have seen the winnowing method. Has anyone seen winnowing method? where farmers generally use mixture of two separate two substances which are different in their densities. Another method is your centrifugation method. So hand picking, sieving, filtration, sedimentation, and decantation. Almost, I think, out of this, most of the techniques you are aware in your previous classes. You are aware of hand picking, sieving, filtration, sedimentation, and decantation. Uh, Evaporation also you may be aware. Okay, so let's discuss about hand picking. When can Likita, when can we use the hand picking method?
So to separate something like so I don't know the perfect definition.
Okay, so but you can apply it. Okay, I think you can apply it that when you can use the hand picking method. So I'm giving when we can use the hand picking method. Here, the substances or whatever the mixed substances are there should be bigger in size. Should be bigger in size means they can be easily spotted with the eyes. They should be easily spotted with eyes. They should be easily able to be easily picked up by hands, and also they should be of different colors. They should be of different color, shape, and size. Okay. So if they have a difference of shape, color, and size, the substances are quite big so that you can hold them with your hands, then we'll be utilizing the hand picking method. For example, suppose if you have mixture of green chilies and red chilies, so you can use your hand picking method. If you have a mixture of onion and potato, so you can use your hand picking method as the substances are easily visible to your eyes and you can easily identify, you can easily pick up them. The size of the particles is big. Okay. So you can easily pick them up. Got it?
Yes, sir.
Okay. Then sieving method. See, sieving method it is we use every day to filter out tea. Whenever we make tea, so we use this method of sieving. So in this method, what happens? We use a sieve and through that sieve, so here we use a sieve which is generally a netted structure and we allow the substance to pass through it. So the substance, here what is the necessary condition? It should be solid in liquid. If there are some solid particles in liquid, you can separate them out by the process of sieving. The condition is that the solid particles, the size of the solid particles should be sufficiently large. It should be greater than the size of these nets. Then you can separate them out by the method of sieving. In the same way, we can use filtration method also similar to this. But for the filtration method, even if the size of the particles are small, then also you can use the filtration method. For example, you will be using the filtration method for a solution of chalk powder and water, where chalk powder is insoluble in water. So you can easily separate out a mixture of chalk powder and water by using a filter paper. Your filter paper has very tiny pores in it. So with those pores, you will be able to separate out the contents of the solution. Got it? We'll see the remaining one. We'll see sedimentation, decantation, distillation in our coming classes. Okay. So in the coming classes, we'll see this further ones. We'll see about all of them. Anyone having any doubt with this?
No doubt, sir.
Okay. Okay. See, even after me informing me during the class that once you leave, you need to leave the class, just inform. Still, I observed that three people, 2 to 3 people have left out without information. So this is not good. Whenever you need to leave, just inform and leave. Okay. Bye all of you. See you again tomorrow.
Yes, sir. Bye.
Sampath? Sampath?
Yes, sir.
Okay. Is there any doubt?